Hi, in this video we'll finish off one of the problems from the auxiliary lines video. So let's take a look at the full problem statement. The lengths of the sides of a triangle are 9, 12, and 15, and a circle with its center on the shortest side of the triangle is tangent to the other sides of the triangle. What is the length of the radius of the circle? Now the natural auxiliary line to draw for this problem is the radius to the tangent point. So let's draw that in. Probably could have drawn that in without even reading the question. Now once you have that auxiliary line drawn in, you can finish this problem in one of two ways. Both are pretty short, so let's do it both ways. One way is to invoke a Pythagoras relationship. And to do that, we need to work out some more of the lengths of this figure. Now once we draw in our auxiliary line, we quickly realize that we generated two congruent triangles. So we can take this length 12 and transfer it over to that side. And we find that this balance length is of length 3. We know that this long length, or short length rather, of this larger triangle is 9. We can draw in the radius of the circle and find that this shorter hypotenuse now is equal to 9 minus r. And at that point we can realize that we have three sides of a right triangle all written in terms of the variable r. So we can now invoke the Pythagoras relationship to help solve for r. So let's go ahead and do that. Let's take the hypotenuse squared is equal to the sum of the squares of the lengths of the legs, 3 squared plus r squared. Expand this. You can cancel out the r's, bring the 9 to the left, 18r to the right. Divide by 18 and we find that r is equal to 4. Now a second way to finish off this problem is to use a similarity relationship. And to do that we have to realize that this small right triangle that we formed is similar to the large right triangle. And they're similar because they're both right triangles and they both share this common angle. And once you make that recognition, you can write the ratio of the long leg to the short leg is equal to the long leg to the short leg to quickly find that r is equal to 4. Again, a fairly simple problem once you draw in the appropriate auxiliary line. So take care and we'll see you at the next video. Bye-bye.